Okay, welcome back. Now, I want to take a couple of minutes here to go over this. So this is the arrow diagram that relates the mapping with the matrices. Matrices, I mean. So what this gives is the relationship between map inverses and matrix inverses. So it's a special case of the arrow diagram that you may have seen in the text that related function composition to matrix multiplication that we talked about before. Now, also, beyond its place in our program of seeing how to represent map operations, another reason for our interest in inverses comes from linear systems. So again, a linear system is equivalent to a matrix equation, as you can see here. So we have this system of equations here, and that's equivalent to taking this representative matrix, right, that we've been dealing with. So there's our coefficient matrix, and then our vector of our x's, and then it equals our results, right, the 3 and the 2. And notice how we could write it this way too, the mapping of a vector, right? So the mapping of the x vectors to a d vector, okay? And if you remember way back to chapter 1, we started with these systems where we had all these linear associations, right? These linear equations of d's, right? d1 through dn. And so now we're starting to come full circle where now we're saying, hey, well, let's look at this in a different way. And so that's where the matrices are coming in. And so we're looking at that from that point of view as well. The fact that a linear system is equivalent to a matrix equation. So now by fixing the spaces and bases, for example, R2 with the standard bases like we did before in the previous video, we could apply it to both sides of G circle H of the x vector. Okay, so if we did that, we could get G circle H of x equals G of D of x. And then what does this give us? Well, this will give us what? X vector is equal to G of the D vector. And then restating in terms of the matrices, we want to multiply by the inverse matrix. So in other words, we want to multiply this by the inverse matrix to get the same result. So let's do this. Let's write it this way. We want to multiply the inverse matrix by the representative with respect to the bases C and D of, and what are we using? X, or excuse me, G. Right? Times with respect to C. And that's going to be the D vector, right? And so what we're hoping is we'll do this product and we'll get the representation with respect to D of what? It's going to be the x vector. Oh, hold on a second. Oh, b, not d. Okay, let's do some examples of this in action.